Hello 171 class, this is another example from 1.6 homework. This is problem number 8 in 1.6, and what we're being asked to do here is to take this graph, I'm going to blow it up here. This is f of x, looks like a piecewise function, two different lines kind of stuck together, and we're going to take this function and use it to graph this function using transformations. So this says 1/2 f of 2x. Alright, now remember, if we're inside the parentheses, that's a horizontal compression. If we're multiplying the x, the original x that wasn't multiplied, we're going to compress this thing horizontally, meaning we're going to go in towards the x-axis. Y-axis. So here's the same graph. And what this basically means is when I have to take, to get g, it says 1/2 of f of 2x. So what it's saying is the g function that we're going to graph in red here, its y-coordinates are going to be half of what the x-coordinates in the f function were after they were doubled. Okay, so let's first deal with the 2x part. The 2 is making these points take place at half the distance that they originally were, meaning that this 0, -6, 0, is going to take place at -3 instead. Okay, now why is that? Because this point has an x-coordinate of -3. If -3 goes in here, it gets doubled. And if you double 2 times -3, you get 0. 2 times -3, you get -6. And at -6, the y-coordinate is 0. So we're having the point because we're doubling it in the parentheses. So we have it to get to the same x value we have after we double. So that's -3, 0 there. Okay, now all these points will be half. Okay, now if you have 0, if you cut it in half, you get 0. Alright, so this point will actually stay the same. It won't go away. Okay, as will this point, 0, 0. If you have 0, 0 times 2 is 0. You still get 0. So if you have 0, you get 0. You double 0, you're still at 0. So this point will also be the same. Okay, I closed that one in. That one's open. At this point, 6, 4. Once again, if I have 6, I get 3. And then if I double 3, I get 6. And that will give me the -4. But oops, I need to make it open. But over here now, corresponding with 3. Okay, again, if 3 goes in, I double it. 3 times 2 is 6. So f of 6 is -4. Okay, but that point is occurring over here now. So the f of 2x, I just want to emphasize I'm not done yet. I'm just doing the first part of it. It's taking this thing, it's compressing it in horizontally. So temporarily, that blue graph, look like that, has become this red graph. Okay, with the horizontal compression. Again, horizontal compression means we go in from the left and right towards the y-axis. Alright, now we need to deal with this 1/2. Okay, the 1/2 is taking place after the 2x goes in to the function. So the 1/2 is taking place on the y's. So the y-coordinates are being multiplied by half. So if we multiply the y-coordinates from our new red graph, if we multiply them by half, that'll give us our new location of the y's. Now, because this number is below 1, what's happening is a vertical compression. So the graph is getting tighter towards the x-axis now instead of the y-axis. So let's take half of these y-coordinates to see where this thing actually really does end up. Alright, half of this y-coordinate is 0. So half of 0 is still 0. Alright, but this y-coordinate, -4, half of -4 is -2. So this open dot down here at -4 is actually going to take place at -2 when all the different operations are said and done. So I'm going to take our line right here, and instead of it going to the bottom down there, -4, it's going to go to -2. Alright, this open dot here, I can get rid of it. Okay, so this piece of the function, it got compressed horizontally, and then it got shrunk, compressed vertically as well. So we end up there. Alright, same thing's going to happen down here. At this point right here that's now at 3, -4, the -4 is going to get cut in half again by this 1/2 right here. The y-coordinate is now being cut in half. So we're going to end up with an open dot right there. And once again move this. Delete. Alright, and then this is what the new graph looks like. It's like parallel to the old graph, and this actual one right here is actually on top of it. That doesn't always happen, it just happens in this case for this problem. But anyway, that's what our new graph's going to look like. So let's go back to the question. Okay, so the two little red graphs, this is the original. Two little red graphs is what we want it to be. And these two are the only ones that go in that direction. If you look, you need to go down and to the left still. The other two go in the opposite direction. So we know it's not A or C, it's got to be B or D. And the reason why I know it's B is because D has -12 and 12 as those x coordinates. And you see we have -3 right here and +3 right here, which is what we have for B. Right, there's -3, there's +3. Okay, so it's definitely B. Alright, so this question is, you have to know how to do vertical and horizontal compressions and what does what when you do the vertical and horizontal compression. Basically, it's this number in front of this, x, is what you have to divide the original x coordinates by. Okay, so whatever number's in front of x, you divide the original x coordinates by. Whatever number is in front of f when you do these types of problems is what you multiply the y coordinates by. Okay, so divide the x coordinates by this number, multiply the y coordinates by this number.